All right, well, I'm sorry I'm not here today. I am out at Chesapeake Middle doing a class where where I'm trying to learn to bring home some great problems for us to do. So, what we're going to do today is two things. We're working on quadratics. We're going to solve them in two ways today. One, solving by completing the square. So that's one way we're going to learn. And then the other way is the quadratic formula. One of my favorite ways because it always works. Whenever you're in doubt, go to the quadratic formula. Note it must be memorized. We'll be singing tomorrow. I'm really sad I'm not here. Okay, here we go. Solving by completing the square. Now I apologize in advance, this video is going to be longer. I like videos to be like 13 minutes at the most. This is going to be a little longer today, so just bear with me. And you guys will be pausing the video to work on problems in the middle of it, okay? Okay, quadratics. We factor, we get two factors, we set them equal to 0, we solve for x. That's what we've been doing. Today we're going to do something different, completing the square. So what we do is, first of all, move the c that we have over to the other side. X squared plus 10x equals 3, okay? So number one, move c to other side. The next thing we do is what we're trying to get is we're going to create a trinomial such that it can be written in a different way as a binomial, one term plus or minus another term squared. So we want to make this conversion, okay? How do we do that? First of all, we get a new c, and let's go over here. C is going to be equal to b over 2 squared. Do it for our problem. Our b is 10. So c equals 10 over 2. We're going to square that. C equals 5 squared. C equals 25. So we move the c we have to the other side. And then number 2, we get a new c value according to our formula. C equals b over 2 squared. Now, so we've got c is 25. We're going to add it here. And it's going to create our binomial squared. But you see, I hope you see a big glaring algebra problem. If we add it to the left, we must add it to the right. Okay? So we did that. Now what we have to do is we're going to write this trinomial as a binomial. And the way it is x plus b over 2, and that is, these are equivalent function. Okay, so in our case, it's going to be x plus b is 10 divided by 2 is 5 squared. Now, first of all, let's prove that, because you might be saying, really? That really works? Now, let's prove it. Let's FOIL this out and see it really is x squared plus 10 95. X plus 5 times x plus 5. First, x squared, outer, inner, that's together, plus 10x, last, plus 25. Okay? So it works. Now, why do we care? Why do we want it? Why do we do it? Side, we've got to balance our equation is 28. So this equals 28. We've created a quadratic that's easier to solve. Because when you have something, how do you solve it? Well, you take the square root. Take the square root of both sides. And when you take the square root of something that already is there, is just the thing itself. X plus 5, right? Because the squared and the root cancel, and I'm left with x plus 5. Not so easy on this side. Positive or negative radical 28. Okay? Now we could apply that. We are not going to do that for today. I just want to keep it a little simpler for this piece. So we're not done yet though, because we don't have, so we're going to subtract 5, and we have x positive or negative radical 28 minus 5. And just, as I just can't stop myself, if we simplify that, it's radical 4 times radical 7, which is x equals positive or negative 2 equals 7 minus 5. That's a good form answer. Okay? Now, if I plug in this x value, there's two of them. There's a positive 28, radical 28 minus 5, and there's a negative radical 28 minus 5. If I plug both of those in to this, I will get 0 both times. This is the root of the function, right? This is a quadratic that is upward, okay, has 2 roots. And if I plug both of these in, I will get a value of 0. Okay, so with calculator, I'll do one of them. Let's plug in radical 28 minus 5 into this equation and show you how that would work. Okay, I'm going to take radical, you see that? Radical 28, move over, minus 5. I'm going to take that whole amount, and then I'm going to add 10 times positive radical 8, move over, minus 5, x value. I multiplied it by 10. And now I'm going to subtract 3. Look, I get 0. If I plug in negative 28 minus, I will get the same thing. Okay, so we did the check. So, did check on calculator. All right, what I'd like you to do is, let's do this one more together, and then we'll stop the video and do the next one. Here we go. I'm going to move the c over. X squared plus 6x, leave a space, equals add 8 to the opposite side. Remember, we're 8, adding 8. Okay, the next thing I'm going to do is find a c value. Okay, well, c equals b, which is 6, over 2 squared, which equals 3, 6 divided by 2, squared, which equals 9. Okay, I'm going to add 9 to both sides. Right? Now what I'm going to do is I'm going to write this trinomial as a binomial squared. Okay, equals, and this is going to be combined to be 7. So this is going to be, remember, b over 2. X plus b divided by 2, x plus 3 squared. Now, to solve, I take the root of both sides. These cancel. I get x plus 3 equals positive and negative radical. One more thing left to do. I've got to get rid of that 3. So x itself, the root of the function, equals positive and negative radical 17. And that is the answer to my problem. I have solved for x by completing the square. So stop the video, do this problem, and see how you do. So, let's see. All right, so hopefully you've checked your answer, and now we're going to move on to the back. Here we are solving a quadratic equation by completing the square if a doesn't equal 1. Okay, this gets a little more complicated, but we can still do it. So to start the problem the same way, we are going to move this 17 over to the other side. 2x squared plus 10x space equals negative 17. Okay, move the c over. Then what we'll do is, so let's lay out our steps. 1, move original c. The next step is going to be factor out. We don't want this 2. To get our binomial squared, we can't have a 2 here. So we're going to factor it out. 2 times squared, we're factoring it out, so plus 5x, leave a space, equals negative 17. Okay, so I'm factoring the 2 out. Now I'm going to account for it later, but there we go. And now what I'm going to do is I'm going to get binomial squared. So I need a c value. C equals 5 over 2 squared, which equals over 4. So I squared that. And what we're going to do is, that's what I'm going to, plus 25 over 4 plus 25 over 4. Now, it's a fraction, you know, it happens. So I could do that in decimals. I'm just going to keep it in fractions here. So now what I have to do is, actually this is not okay right here, because this was my c value, but I can't add this. because I haven't accounted for this that I pulled out. Notice, because this is all in parentheses, this 2 must be multiplied to this. So I multiply this by 2, okay? And in this case, it cancels, and now I have 25 over 2. So what I have now on this side is negative 17 over 1 plus 25 over 2. Okay, I know how to do fractions. I get common denominators. This becomes negative 34. And this is this negative 9 over 2. Okay? So, okay, now what does this become? This becomes 2 times x plus b over 2. Well, we saw that b over 2 is 5 halves, so it's x plus 5 halves squared. Okay? So now I have this equation that's in green. 2 times x plus 5 squared, or 2 squared, equals negative 9 over 2. So the first thing I want to do in solving this is I've got to get rid of this 2, because I want to take the square root. So how do we do that? Well, we divide both sides by 2. Okay? And notice how when I went to divide, I wrote it as a fraction because I'm dealing with fractions, remind myself what I'm doing. So these 2's cancel. I'm left with x plus 5 over 2 squared on the left, which is what I want. Do this division. Remember, division of fractions is multiply the numerator by the flip of the denominator. So that's what I'm doing. And then this negative 9/4. So here's my problem. Let me write it again so we can see it. All right, it's x plus squared equals negative 9/4. Okay, so now what I'm going to do is square root. So when I take the square root, what do I find? Find that I'm getting, this becomes x plus 5 equals imaginary number. Okay, so we're going to break this up. We've got the square root of negative 1 times the square root of 9/4. Well, x plus 5 halves equals, this turns into an I. Square root of 9 is 3, the square root of 4 is 2. 3 halves I. And my final answer, I got to get rid of this negative 5 halves, is equals, what did I forget? I forgot positive and negative. Positive and negative 3 halves I, positive and negative 3 halves I, minus 5 halves. So, not your run-of-the-mill problem, but there you go. When a greater than 1, more complex. Okay? So in this case, you might not want to, unless do complete the square. So there's another quadratic formula. All right, so here is the quadratic formula. X equals negative plus or minus of b squared minus 4ac all over 2a. Okay? So, trust me, you'll be glad you did. Okay, because we have to memorize that. And it's wonderful SAT tests like that. How do we use by using the quadratic formula? Notice that it's all about A and C. So we need a standard, right? Well, we have a standard form equation here, but we have to get it equal to 0. So the first thing we do is equal to 0. So we have squared plus x minus 5 equals 0. Now let's label C. A, B, C. A is 2, B is positive 1, C is negative 5. Okay, it seems silly, but with formula, you need this very clear. Here we go. Then now let's just plug and chug. X equals negative 1 minus the square root of b squared minus, now I like 4ac all in parentheses. You've got to keep track of your negative signs. So 4 times 2 times negative, okay? So all over 2 times 2. Okay, and now I just got to do it. E negative 1 plus or minus the square root of 1 minus 4 times 20 times 2 is 40, and you've got 2 positives and a negative, so this is going to, okay, so it's negative 40, right? All over 2 times 2, 4. Let's keep working. E negative 1 plus or minus the square root. 1 minus a negative is plus, the 41 all over. All right? So we cannot simplify 41 anymore, so we are done. The only thing we could do is to divide the fraction, split up the fraction into two pieces. This is a fine answer. I just want you to be able to recognize this form. So I could write this as, it's also equivalent to -1 plus or minus 41 over 4. And sometimes that's useful if this is if we can simplify that. Okay, it's useful, sometimes it's not. But either of those will work. You know, it's a lot. Let's do it again. Okay, so we're going to do one more together, and then you're going to do one. So here we go. Ugh, well, this looks awful. So let's see if we can make it a little more palatable. The first thing we need to do is get everything over to the left. 1/16 x squared plus 5 halves x plus, this is -25, so plus 20. I'm going to put it over 1 because I've got all fractions, so we got to figure this out. Okay, the first thing you want to do is get rid of all those fractions, and since they're even, you can. So what I'm going to do, multiply the entire equation by 16 to get rid of all those fractions. Whatever you do to the left, you have to do to the right. So here we go. These will cancel, giving me x squared. Here, this 2 will cancel, and this will be 8. Now I'll have 8 times 5x plus 4x. Now this doesn't cancel, so I have 16 times 25, which I will make sure I do that right. 16 times 20. That is 400. So plus 400 equals 0 times 16 is 0. Okay? So now I'm going to solve by the formula. So let's list A, B, and C. A is 1. B is 40. C, positive 400. Start plugging and chugging. X equals -40 plus or minus the square root of 40 minus, keep your brackets, 4 times 1 times 400. Okay, so I hope you're seeing here what's going to happen. Number minus a number, and if this is larger, then we're going to have an imaginary number. Okay, we got to keep this 2a. Okay, so this equals -40 plus or minus the square root. So if I were 40 squared, I get a 1600. 1600 minus, so that's going to be nice. So if you multiply this out, it's going to be the same thing, right? Times 400 is 1600. So I get 1600 minus 1600, that's nice, all over 2. So this equals -40 plus or minus, this is 0. So plus or minus 0. So this whole piece came out. So it's just -40 over 2. X equals -20. Notice, fundamental theorem of algebra says I must have I only got one. The issue is when you have this value becomes a 0, this is a double root. And we're going to learn more about that at the bottom of the page. Double root. Okay? So, okay, let's leave that for now.